These are the pH notes. So what is pH? pH is something that we talk about when we're describing acids and bases. And what happens is that acids dissociate or break apart in water and give off H plus hydrogen ions. So if we look at something like HCl, hydrochloric acid, we can see that hydrochloric acid is going into this beaker of water. These are our water molecules right here. And what happens is that when that HCl gets broken up, we have those hydrogen ions that get broken off from the chlorine ions. And those hydrogen ions are what define pH. And so with that, we are looking at, yes, there are also chlorine ions in this solution. And so those hydrogen ions are what is vital for something to, for us to define pH. So what's an easy way of representing the concentration of hydrogen ions in a solution? Well, when we're looking at this, if we have hydrogen ions, we can easily go through and think about the fact that, well, if I have HCl, then that means that I'm going to have however many hydrogen ions that I had for that HCl. So whatever our concentration of our solution is going to equal the concentration of our hydrogen ions with that. So those concentrations are going to be equal. These hydrogen ions are going to pair up with water. So we see this H2O and then we see that H+. Those can pair up in water to form hydronium ions. Sometimes when you're talking about acids and bases, you will see it referred to as those H+ ions. You can also see these hydronium ions, which is what if this hydrogen paired up with that H2O. And so just one thing to note, because the pivot we're going to look at is using this H3O+, the hydronium ions, we're going to treat those the same. So for our purposes, we'll treat H plus 1 and H3O plus 1 as the same value. Part of the reason we can do this is because we're only going to look at strong acids. There is such a thing as weak acids, but they get really messy. So for our purposes, these are going to mean the same thing. We are going to use in the notes this H+1, but in the pivot, you are going to see that H3O+. Or if you're doing other work on the internet, kind of looking for other things to help you out if you're struggling, you could see both of those. All right, so what does pH tell us? pH, we know that in an acid, our acids dissociate and break apart. So then we have hydrogen ions. So what pH tells us is, and you'll notice there's that H in there, it's telling us something about the H+ ions that we have. So pH describes the hydrogen ion concentration of a solution. And again, with that, or this hydronium ion concentration, those are interchangeable. So we calculate pH for a solution using the ion concentration. So pH is going to equal negative log of our concentration of hydrogen ions with that. Square brackets around a chemical or an ion is shorthand for saying the concentration of that substance in a solution. So we don't have to write out concentration. And that is always going to have a unit of molarity. And so when we look at this, we can read this to say I'm reading this formula here. So pH equals the negative log of the hydrogen ion concentration. So we would need that concentration in molarity. We would plug that in. So solutions with a lower concentration of hydrogen ions have high pHs. So low concentration means a high pH, and those are basic. pH of 7 is neutral, and at room temperature, pure water has a pH of 7 that has like a medium concentration. And then solutions with high concentrations of hydrogen ions have lower pHs and are acidic. So if you have a lot of H plus ions, that is going to tell you that you have a really acidic solution. So that pH scale, lower pH values, so 0 to 7, 7 is being that neutral. Lower pH values mean those solutions are more acidic, so there's a higher concentration of H plus ions. When we're looking at this, that means that a high pH, it's just the opposite for each of those. High pH equals less acidic or more basic, which means a low concentration of H plus ions with that. It is possible to have a pH of less than 0 or greater than 14 because the pH scale is a logarithmic scale and just some other factors that there are. All right, so calculating hydrogen ion concentration, which that's what this means. Hydrogen ion concentration. How do we calculate that concentration, H plus, if we know the pH? Well, we have this formula that defines pH. pH equals negative log of hydrogen ions. So if we rearrange that, if we kind of use our math brain, then the negative is going to go over to the other side. So we get a negative pH. And then how do we undo a log? Well, this is log base 10. So when we rearrange that, we get this equation on the right. So we can find the hydrogen ion concentration by doing 10 to the power of negative and then the pH value with that. So these are the two formulas that we're going to have, and we go back and forth. And pH is just a way for us to get a nicer number, because these hydrogen ion concentrations, these H plus numbers, can be really, really small. And so it helps us so we're not using scientific notation. That's how that pH scale is going to help us. All right, so if we go through some examples of doing some calculations for between pH and our hydrogen ion concentration. So what is the pH of a solution if the hydrogen ion concentration is 7.2 times 10 to the negative 7th molar? Because this is a concentration, those hydrogen concentrations are always going to have a molarity unit. So first step is picking our equation. So what is the pH? We're looking for pH. So we're going to pick the equation that has pH by itself, because I want to be able to plug in the value I know into my calculator on the right side, and then it's going to spit out my value for pH. So I'm going to use pH equals negative log, and then I can plug in that hydrogen ion concentration, 7.2 times 10 to the negative 7th molar. So I plugged in my value, and now I need to just go plug this into my calculator. Couple tricky things on the calculator, depending on what calculator you're using. This is a negative, not a minus sign, so some calculators are funky with that. And then we just want to be careful because we have scientific notation. You might be using a different calculator at home, but as we look over here, these are the calculators that we have in school or in person. And with that, if I was going to type this into my calculator, I'm going to type negative. Log is down by the second button. Then I type in my 7.2. And then to get my scientific notation, I can do two things. I can use that EE, that capital E button, or I can just type out times 10 to the negative 7. Negative 7, making sure you're using the negative button instead of the subtract button. Those are not equivalent buttons with that. Once you type that in, and make sure you give it a try in whatever calculator you're using, the pH of this is 6.1. And there are no units on pH because it's in that name that we are defining how many H's, what is the concentration of our hydrogen ions that we have. All right, number 2. What is the pH of a solution if the H plus concentration is 1.4 times 10 to the negative 2 molar? Well, again, we're looking for pH. What is the pH? I have this H plus value, so whichever equation has that H plus value on the right and has pH by itself, because that's what I'm looking for. So I'm going to use this first one again. Step 2, plug in the value I know. I know that my H plus concentration is that value I was given. So I can go ahead and say pH equals negative log of 1.4 times 10 to the negative 2. I'm going to go to my calculator and figure out what that is. All right, calculator error, sorry. I got 1.853, and then that keeps going. I'm gonna just round to 1.85. No units on that, but we could say pH equals 1.85 for those. All right. So number 3. Nope, number 2. Mine are in the wrong order. All right, number 3. So pH and H plus. So what is the H plus concentration, hydrogen ion concentration of an acid if the pH is 1.8? So now that I'm solving for H plus, I'm going to use that second formula. pH is 1.8, so that's going to get plugged in where we see pH. So I picked my equation, that second one, plugging in the value I know. I'm solving for H plus concentration. That equals 10 to the negative pH. So plugging in the pH from my problem, 10 to the negative 1.8. And I'm going to just type that in. Looking over here, typing that into our calculator, 10 to the power of, again, that negative button, and then 1.8. And we got 0.0158. And then this one is a concentration. So anytime you have a concentration, your units are molarity. So capital M for our units. All right, number 4. What is the hydrogen ion concentration of an acid if the pH is 8.2? And actually, this would not actually be an acid. This would be a base because the pH is higher than 8.2. Go ahead and give this one a try. The answer is down there for you. All right, example 5. This one is a kind of a 2-step. Find the pH of a solution if 4.1 moles of hydrochloric acid are dissolved in 45 liters of water. Well, with this, if we're going to find pH, in order to find pH, we need to have a concentration of hydrogen ions. We know that there are going to be as many hydrogen ions as there are HCl's. So let's first find what is the concentration of the solution. How much HCl do we have? So going back to last unit, molarity is moles divided by liters. And so I know I have 4.1 moles of my acid in 45 liters of solution, which means that I'm going to get 4.1 divided by 45. And I got 0.0911 molar. Well, that's the concentration of the solution, but that also tells us how many hydrogen ions we're going to have, because it's always going to be that just one hydrogen ion breaks off. So then now we know our hydrogen ions, so now we can go and step 2, use our pH equation. pH is going to equal negative log of whatever that concentration we found, 0.0911. And we can plug that into our calculator. I'm going to make sure that I have the correct answer as the bottom. And I got 1.04, and that continues on. But I'm going to just round that to 1.04. pH, again, doesn't have a unit. So just 1.04 is our answer. Or you could say pH equals. All right, here are 2 for you to try. Answers are provided and some things to note are at the bottom. Reach out to your teacher if you have any questions, and there should be a worksheet and a check-in for you to try. Good luck.